Assalamu alaikum. This is me and Jamil Rahman from MTSB. Today I am going to present my Proteus circuit that consists of basically three sensors: a current measuring, voltage measuring, and a temperature measuring, with an additional RTC clock that will tell us the time, date, and the specification at which time on which the reading is recorded. Starting from the first sensor, ACS712. ACS712 is a current measuring sensor. It is being used for measuring AC and DC both currents. It has different ranges available in 5 ampere, 20 ampere, and 30 ampere, and it measures current varying from positive 5 to negative 5 ampere and so on, like in 20 and 30 ampere modules. It provides isolation from loud, easy to integrate, and scale factor. It works on the principle of Hall effect. It consists of a VCC pin, an output pin, a ground, a wire in port, and a wire out port. That's the basic structure and configuration of this sensor. Heading towards second sensor, uh, this one. This is basically a real-time clock. The model I have used here is DS1307. It is a serial real-time clock that requires a very low power, full binary coded decimal clock calendar plus 56 bytes of NVSRAM. A few benefits and features of this are: it completely manages all timekeeping functions, real-time counts, seconds, minutes, hours, dates, and so on. 56-byte battery back general purpose RAM, and a programmable square wave output signal. And one more thing, it has a 8-pin DIP and 8-pin SO that minimizes the required space. This is a virtual terminal, basically a screen that depicts all the readings that are gathered from the sensors, depicting the stored readings. Heading towards our next sensor, this is a DHT11. This is a temperature sensor. I've used a model of DHT11. It consists of three pins, as you can see, a VCC, a data, and a ground. It operates between a voltage of 3.5 to 5.5 and a zero point 0.3 milliamperes of current. It gives us output in the form of serial data. Humidity ranges from 20 to 90%. Temperature ranges from 0 to 50 degrees centigrades. It has a pretty good accuracy, having plus minus 1 degree centigrade and plus minus 1% in actual. Resolution shows that temperature and humidity are both 16-bit. It is connected with a major Arduino board. The Arduino board which I have used is Arduino Mega 2560. It is a microcontroller board based at on the 80 Mega 2560. It has a standard 54 digital input output pins, of which 15s are used as PWM outputs, 16 analogs, 4 UARTs, 16 megahertz crystal oscillator, a USB connection, a power jack, and an ICSP header, included with a reset button. This, ladies and gentlemen, is a SD card holder connected with the Arduino board that stores all the information in it, all the information gathered from the sensors. In the last, as a voltage sensor, I've used a potentiometer that varies the output voltage as well varies its resistance. Nothing more to explain in it. It is a very simple device connected with the same Arduino board on the left side. After explaining the hardware, I'm going to explain my Arduino code. Arduino code is basically the command which is given to the microcontroller board in order to act on it. In the starting, you can see that there are four libraries, as in the start of every coding language libraries are added. The first two libraries are used for the SD card module, the SPI and SD, as you can see, and the DHT and RTC libraries are for the temperature sensing DHT11 sensor, and the RTC is for the RTC clock respectively. After that, in the second part of the code, I'm defining my variables. As you can see, sensitivity 185, ADC value 0, offset voltage 2500, and all that. Defining the values, there is another process of defining the pins. Technically, this is the definition of the pin at which the specific sensor is attached. My DHT sensor is attached to pin number 6, so I have defined here the pin number 6 as my DHT sensors pin. After the definition, I have created a file by the name of my file. This will store all the information gathered from that sensors in the circuit. After defining the storage file, I will go through a void setup function. That is a loop to basically check whether all the sensors and the components are connected or not. It runs and first checks that if the RTC clock is connected, and if it is connected, it just allows it to store date and time, and if it isn't connected, it depicts the message of couldn't find RTC clock. Similarly, same goes in the process of your SD card. If it is connected, it is initializing, and if initialize is phase, it means that the SD card is not connected. After that, after checking all the parts of this file closes. For now, this file closes, and a new function pop-ups. That function is the logging time. Now, this logging time function gives the command of storing and displaying the time at which the specific reading is taken. Now you can see first myfile.print is giving the command of storing the specific year, time, month, hour, minute and second in decimals. After storing it, you are giving the serial print command in order to display that specific information. After displaying all that, I've given a delay, and similarly the file close procedure that we have done above. After ending of this void logging time, we have defined another function named as void logging temperature humidity. Now, after we have done with storing and displaying our time and date, we have to also display the temperature at that specific point. In order to display that temperature, we will similarly just ask the DHT11 to display our temperature, take reading, store it, and to display it, and similarly the file will be closed. Here you can see in the function of logging temperature, I have done the same thing as I have done in the function of logging time, just storing the value of temperature and humidity and just printing it, nothing new. Now we will head towards our last function, that is the main function. I have named it as void loop. Here it is, the void loop function. It starts from now what we have left is our current sensor and our voltage sensor. Now first of all, we will take up with our voltage sensor. It will take readings from the voltage sensor and do specific calculations in order to convert it, and then stores and display that voltage. Here in this, there you can see the commands of storing and displaying it. The raw sensor value is also displayed on it, and the calculated value in millivolts will be also displayed. Similarly, in the case of current, you will do the same. Just take up the raw sensor value, display it, taking up the value of calculated value, and just display it. After that, we will give a delay of 15 seconds, and we will call both of the functions we defined above, the logging time and the logging temperature. Delay of, and that code will be ended. After explaining all its structure and coding commands, I will just run this project. I have given all the voltage values as needed, and I've just turn off my switch that is already turned on, not turned off, apologies. And we will just, I've already uploaded the hex file of the code which I have explained before in this Arduino board. We'll just run it and just see what is the output we are having from this project. For the sake of showing results, I'm using a different screen recorder, as my last screen recorder that was of default Windows screen recorder was not recording the results. Now showing you the results. Here you can see the specific sensors are calculating are measuring the values and showing them in front of you, the voltage value, the raw sensor value and the converted value as well of the current, the humidity, the temperature, and the loop iterates to infinity with a specific time interval of 6 seconds. Heading towards our secondary project, which is based on a simple sensor known as a PIR sensor, which I have used in order to detect motion. As you can see, there are three components in my simulation. Arduino mode, that is the same one as I have explained in the previous project's video. It is Arduino Mega 2560. This is a virtual terminal similar to display all the readings that we have gathered from this sensor. This is a PIR sensor based on infrared principle. A PIR sensor itself has two slots in it. Each slot is made of special material that is sensitive to IR. The lens used here are not really doing much. And so we see that the two slots can see out past some distance. When the sensor is idle, both slots detect the same amount of IR. The ambient amount of radiation from the room or walls or the outdoor or somewhere where the sensor is placed. When a warm body or a human or an animal like something passes in front of this sensor, one half of the PIR sensor, which causes a positive differential change as there is a change difference in signal, as there is a difference of IR signal that it receives, and this creates a positive differential change between two halves. And this differential change is measured, and it allows the virtual screen or the display to show that a motion is being detected in front of the PIR sensor. A PIR sensor itself is housed in a hermetically sealed metal in order to improve noise, temperature, humidity, and immunity. There is a window made of IR transmittive material that protects sensing element. Behind the window are two balanced sensors. One question that I have experienced during the research of PIR sensor, it was a very common question asked over the internet: do PIR sensors work in daylight or not? They of course do. Definitely they do work. Daylight don't have any effect on the PIR sensor. Heading towards the code of PIR sensor, heading towards the explanation of the Arduino code, which is being used in my PIR sensor circuit. Starting from the definition of the pin on which the PIR sensor is attached, there are some defining the types of variable which are used, some return types, and they're introducing new variables. This is a very important variable which we will use to show that if the motion is detected or not. A void, standard void function with serial begin 9600. Here is the main loop in which all the process runs. It has two if else conditions. In the first half, the digital read pin finds the PIR pin at high. It gives a PIR value of 1 and shows that the lock low is false. In addition, with printing that motion is detected, making true the other Boolean expression which we have explained here. We have defined here two Boolean expressions. In the other half, if the digital read pin find PIR pin at low, it stores the information of low in millis, which acts as a constructor, take low time as false, and if millis minus this variable is greater than pos, then it gets PIR value 0. It makes lock low true, and a message of motion and it is being printed on your screen with a delay of 50, and here ends the code. Heading towards the simulation or the working of this circuit, now I will run and show you that what outputs it is giving. One thing that I have missed in explaining the circuit is that this toggle which I have used in order to give it a signal as test, as I cannot virtually move something in front of sensor while in soft form. You can see, as I don't have given any signal to the PIR sensors, there is nothing on the screen. But as soon as I changes this signal to one, the motion is being detected, and then afterwards, if I change it back to zero, it again moves towards motion ended. It takes some time. Here it is. This was an explanation of a basic PIR sensor. Thank you very much for watching. May you have a good day.